Get started. Today we're going to do day 8, which is graphing square root and cubic functions. Graphing square root and cubic functions. This is the last thing that we're going to learn before we take our test. Sorry, before we take our quiz for spring break. So today we're learning the last day, and then next class we're going to have a practice, and then the next day we're going to have a quiz. And then the last thing that we'll do before we get out for spring break is the district assessment. That's kind of what we're looking at. Again, today is graphing square root and cubic functions. First thing that we're going to do is look at the parent functions. So the parent functions are the basic shapes of these graphs. And one way you can think about it is, what are you doing to the x value? So here we're square rooting the x value. Here we're cubing the x value. The basic shape of a square root, the way that I remember the basic shape of a square root, is that it kind of looks like the symbol of a square root. The basic shape kind of looks like that. Kind of has that shape. Kind of looks like that shape. That's the shape of a square root. So if we plugged in 0, the square root of 0 is 0. And then the next perfect square that we have is 1. Square root of 1 is 1. And then the next perfect square we have is 4. What's the square root of 4? 2. So we go up to 2. We go 4, 2. And then the next perfect square would be 9. What's the square root of 9? 3. We run out of graph, but it looks like that. That's the basic shape, the parent function of a square root.
So when you square rooting a graph, we're doing perfect squares.
That's what I would graph. And usually I stop there. Sometimes you can fit 3 on there, but most of the time you can only graph over 1 up 1, over 4 up 2. Sometimes you can get to 9, not often. And that is the basic shape of a square root function. We're going to take that basic shape and we're going to move it up, down, left, right, and we could reflect it. But it's still going to have that same basic shape. And so one thing that's really important is this starting point right there. That's our starting point. And that starting point has a very special value. And when we get our equations, it's going to be HK. A cubic function has this basic shape. Something like that. To get our points, we can also start at 0. And then I'm going to cube. And that means multiply something by itself 2 more times. So first I'm going to go to 1. So what's 1 times 1 times 1? 1. So I'm going to go over 1, up 1. Okay, let's do 2. We go over 2. What's 2 times 2 times 2? 2 times 2 is 4. 4 times 2 is 8. So it'll be 8. So we go over 2 and then we go up 8. It's actually off the graph just a little. Cubic graphs have symmetry. So as soon as you do this side, it has symmetry the other direction. So I'm going to do that the other direction. Cubic graphs have symmetry. Oh, also, I forgot to mention here why we don't have negative numbers. What happens when you take the square root of a negative number?
Zero.
Square root of 0 is 0. Elijah, grab a calculator and tell me what happens if you do the square root of any number. Any number, negative number,
Oh, it's in there.
gives you an error. So we don't have negative numbers for the square root. That's why it doesn't have the other half of this graph.
So it's gonna be-
It's just, that's the reason why this graph creates. Because you don't take square roots of negative numbers. It doesn't mean that we can't scoot it over into the negative area, but that same basic shape, that's why it's just a branch like that. You could, but that's just why, like this part, this graph, you graph one side and then you can graph the other side. The reason why you don't have another side to this graph is because you don't take square roots of negative numbers. Oh, let me go. What do you need? So far, so good. But I'm only at like 200 pages and there's like 600 pages, so I feel like I'm just getting to the juicy stuff. For the cubic graph, there's also a really important point, and it's that center point. And that is also HK. We're going to talk about that in a second. We got some really, really hard questions last class. Name something the lawnmower might accidentally roll over.
Snake. Boy.
That'd be kind of morbid. When you mow, what things do you have to move? That'd be awful. I think that's a good one. I got lots of poop in my backyard.
Dude, right there?
We got bunnies.
How would you accidentally warm?
Yeah, like
I tend to agree. I feel like that's one of those things that stays in front of you. I don't know about those answers. I don't know about those. All right, so transformation, something that's important to know, that transformations work the same for every function. Transformations work the same for every function. So we've got a couple of things, a couple of letters. We've got, and they're in the same place. You've got before the X, with the X, and after the X. And it doesn't matter if it's the square root or the cubic function. You have before the X, with the X, and after the X. So before the X, that's the A value. And what it does, it could reflect. Or, I guess it's and or, because it could do both. I'm not going to put or. It reflects. Another thing that it does is it stretches. Stretch or compress. H. H moves your graph left or right, and so it's with the X value, so it moves in an X direction. The X axis is this way, so that's which way the graph moves with the X. It moves left and right with the X value. So one thing that's important to know, it does move left and right, but it moves opposite. And it moves opposite because it's got the little negative right here and a negative right here. So it moves left and right, but it moves opposite. If you've got +5, you move to the left. If you got -5, you move to the right. So it moves opposite. K moves you up and down. So we already talked about this. HK for a square root is going to be the starting point. HK for a cubic is going to be the center point. Got your starting point and your center point. So again, in front, it can reflect or stretch left and right, up and down. How come you don't sit right there so you don't have to sit backwards? Same thing with you, Keith. I don't understand.
Right.
Okay. Right? Doesn't that make sense? Is it better for you? I think it will be. I think it's going to be better. Name something people get stuck in. What? Oh. DBT. I thought you were saying dead, and I was like, what do you, I don't understand.
Who's getting stuck by the word? Bed. Already over there. Come on. See,
Yeah.
oh my God.
I wasn't thinking that. A snowstorm or in a relationship.
See, now I can see that. That's possible.
Yeah. All right. So first thing that we're going to do is describe these behaviors. And so it doesn't matter if it's a cubic or a square root, like how we describe them is going to be exactly the same. So again, there's a number in front of the X, with the X, or after the X that we're going to describe. So this one has something in front of the X that can either reflect or stretch you. Okay, well, it's not a negative. Negative is what reflects. This one is stretching. And so we could say stretch. By 2. and it's a vertical stretch. We're gonna stretch by 2. The 3 in here, it moves you left or right, but it moves you opposite. So when it's -3, it means that it moves you right 3. And then at the end, this means up 1. Let's do some more. This one has a negative out front. That means that it's reflected. So it's reflect over x. Because it's a positive 2, it moves opposite. So it is going to go to the left 2. And then what does the -4 tell me at the end? Down 4. Yep, down 4. All right, this one leads with a negative, so it's also reflecting over x. There's nothing with the x, it's by itself, but there is a number after, so the number after means up 1. Bless you. This one has a number in front, that means stretch by 3. What does the -1 tell me? Right 1. And then what does that mean? Down 3. You can probably bet that on your quiz, you're going to have a question. It'll probably be multiple choice. And it'll probably do something like give you an equation and ask you what the transformations are, something like that. So you have to be able to look at an equation and identify transformations. For these, we're going to work backwards. I'm going to give you graphs and you have to be able to write equations. Writing equations is not that bad. First, you have to be able to identify the shape and what kind of graph it makes. This one's a square root graph, a cubic graph, a square root graph. And then the most important thing is that you got to be able to identify the starting point or the center. Like that's half the battle. So you got to identify the center point or the starting point. So for the first one, that point is -3, 1. What's the point for F? What's this point? What's this point? 1, 2. And what's the last point? -5, 5. Okay, I'm going to show you how we use that information to be able to write our equations. So one thing that I do want to make sure that I note is that over here I'm reflected. Okay, this one's reflected because it's facing down. Does everybody see how that one is reflected compared to this one? Okay. So to create my graph, they'll all start out similarly. So I have f of x. If it's a square root graph, then I'm going to have the square root of something with the x. I could set this one up the same. I'm going to have f of x. And I'm going to have something with the x. And I've just got placeholders. There's a number that could go in front or something that could go in front, inside, or at the end. So for this one, there's no stretching and it's not reflected. So nothing goes in front. In fact, any of the questions that I give you, it might be reflected, but I'm not giving you anything that's stretched. So what we do with this number is we put it into our equation. We have to remember that this is representing H and K, but H moves opposite. So if that's a -3, this has to be a +3 right there. So the numbers that I'm plugging in, this got to be +3. And then the number, the K, just goes at the end, +1. It's always the first value. So over here, I'm reflected, so I have to put something in front. I'm gonna have a negative out in front. And then when I take this point, it's gonna go into my equation as +5 and +5.
Oh, so it's not no number, it's just a negative,
Just a negative.
that's when it's reflected.
Yep.
So what kind of questions will be?
It would be stretched or compressed, but I'm not gonna have you write the equation from a graph with something stretched or compressed. I think that you should be able to identify like this, but I'm not gonna actually have you graph or give me an equation from a graph that's stretched. From this one, we're gonna do it basically the same way. It's just got a different setup for the equation because we've got something to the third power. So it's gonna set up, instead of having a square root, we have x to the third power. It's not reflected, so I'm not gonna write anything in front. And the way I plug in this point is the same. So it's gonna be -1 + 2. And they go in the same order you see them in the equation. -1. And then +2. That's like the hardest thing for a lot of people is writing equations. You can do what? Is anybody still copying these? Any questions? So far?
What like? So, based on what you're thinking. What question, what kind of questions will you see most of this? I don't know.
I'll give you the practice worksheet. Remember, I always have you practice and then I'll give you a warm up beforehand. Name something Hawaii has more of than any other state.
Sorry. And hula hoops.
Luau? Luau? What?
I mean,
You think so?
yeah. That's a good one. Yeah, we definitely did that.
Yeah, maybe because they're so isolated. Yeah, there might be more natives. What is it?
Oh my.
Oh,
Are you serious?
flowers.
Palm trees on LA.
Or I think there's some in Florida too.
Bro, there's palm trees all throughout Vegas.
You know, the Puerto Rico, the Virgin Islands.
There is a lot of palm trees other places too.
I saw palm trees once a year.
Yeah, there's palm trees here.
There's palm trees here.
Yeah, they're not, I don't feel like native,
Yeah, they're not.
but they can grow here. They can grow here. All right, this is the last thing that we're gonna do, and I'm gonna give you a break to do the homework, and then we'll come back and do the graphing. These are words that we're gonna turn into equations. And as I give you words, they're gonna go fit into the equation in the same order that I give them to you. There might be a stretch or reflect. There might be a left or a right, and there might be an up or a down. Okay, so when we set them up, you first look at what type of equation is it. So I'm gonna set up the basis of my equation. So f of x, I'm gonna leave myself a little space, square root, and I'm gonna put x. And I'm gonna do that the same place that I see down here, where there is also a square root. That I leave myself a little bit of space, and then I do the square root of x so I can plug in something to these three spots if needed. I'm going to do the same thing for the x cubed graph. I'm going to leave myself a little space, and then I'm going to put x cubed and fill in the blanks. Hello? Yes. I sure will. Bye. Rebecca, you got Saturday D-Hall. You have D-Hall, Saturday D-Hall? Huh? The ISS teacher, you come up here and you go to ISS, I believe. Who's had Saturday D-Hall before? Anybody?
Who's that, like Saturday detention?
I mean, after school, you could go down there and you could ask them, or when we're done with notes, you could go ask if you need more information. I assumed you got information already about it. Yeah. So we're gonna fill in the blanks here, just reading. Okay, stretch vertically by a factor of 3. That means that goes out in front. Shifted right, that means I'm gonna have a -2. And shifted down 1, so -1. The next one, reflected over x. That means I'm gonna have a negative out in front. And shifted up 5 units. Okay, up and down is at the very end, so it means nothing goes in here. And then I have a +5 at the end. So it's okay if it's blank. I've got a little weird space here, but that's fine. Here, I'm compressed vertically by a factor of 1/3. I'm going to put that out in front. Shifted left, so that means +5, down, -4. The next one, reflected over, that should be the x-axis. In fact, on your homework, I think it says y-axis as well. We're not doing y reflections. Reflected over the x-axis, so I gotta have a negative, and it's stretched by 4, so I have to have a -4 out front. Right 5 means that I have -5. And there's no up and down, so I don't put anything.
So, B is just X cubed plus 5?
D or B?
B.
Yeah, so I mean, if that is weird to you to have that little space, this is the same thing as f of x equals negative x to the 3rd power plus 5. It's the same thing. But I just set it up so that when I have a cubic, something could go there, something could go there, something could go there. So I just left myself placeholders. So I probably should have written this as stretched. I'm not going to have you graph it. I just need you to know where it goes. If it's stretched or compressed, it goes right in front. That's where it goes. That's what I want you to know. I'm going to pause right there and give you guys some homework time. At this point, you can do the entire front page of the homework. Those equations down at the bottom are easy peasy, so you can get questions 1 through 8 done right now. So, welcome back. We're going to graph. And once we know how to graph, that's the last thing that we are going to learn, really. It's the last things we're doing before spring break. So let's graph. First thing that we need to identify is that HK point for everything. That's going to really help us graph. We also have to know that basic shape. So I noticed that this one is a square root, so it's gonna have that shape almost like the square root symbol. So I know this one's, when I go to graph it, it's gonna have that shape. The second one, I noticed that it's negative, so I'm gonna give myself a little note that it's gonna be a shape like this. This one, that one is also a negative, so instead of facing up, this one is gonna go down first. Like that. And this one is positive, so this one's gonna have this shape. It's kind of helpful to give yourself an idea of what the shape's gonna look like before you throw it on there. And we should have an idea of the basic shape of them. For this one, I can identify that point, and I'm gonna go through and I'm gonna identify that HK point for everything. For A, that point is gonna be -5, 1. It's always opposite of anything that's with the X grouping. For here, what would the point be? -2, -4. What about for C? Is there anything with the X grouping? So it's going to be 0. Very good. And what about for D? +1, -3. All right, for each one of these, the way you start your graph is by plotting that point. That is either your center or your starting point. So for A, I have to go -5 and then 1. From there, to make that basic shape of that square root, I think of perfect squares. So I can go over 1, and then square root of 1 is 1. The next perfect square I have is 4. Square root of 4, I go over 4, and the square root of 4 is 2. So 1, 2, 3, 4, and then I'll go up 2. The next perfect square is 9, so I could go over 9. So that's 5, 6, 7, 8, 9, and then I could go up 3. 1, 2, 3. Put a point. And that's all the points I can put, and I will connect the dots. And I look like that. I'm going to make all my graphs, and then I'm going to go back and do the domain and range. So for this one, same idea. I'm going to go put my point at -2, -4. There's my point. This time, instead of when I move over 1, I'm going to go down. So square root of 1 is 1, but I'm going to go down because it's got to have the down graph. Then I'm going to go over 4, and the square root of 4 is 2. So I go down 2. I don't think I can do any more. I think that that's probably as far as I can get. That's my graph. For my next graph, I got to plot that point 0, 1. So I'm not going left or right. I'm just going up 1. From my center point to create my curve, normally I go over to the right and then I go up, but this one's going to go over to the left. And 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So I go over 2 and then I go up 8. So that's going to be like way up here. So my graph on this side is going to go up like that.
Wait, what you said, what's the second?
Do what?
You said was the other one, the other square root?
Here?
No, this one.
This one, you're not doing any square roots, but it's like you go over 1. 1 times 1 times 1 is 1. So you go up 1. When you go over 2, 2 times 2 times 2 is 8. So you'd have to go up 8 and put a point. But it mainly is going to make this diagonal line when we graph them. This one, negative or 1, -3. So you go over 1 and then down 3. This one's a positive graph. So it's basically going to make this diagonal line of points when it's positive. And then you just have to make sure that you connect them not as a line. You connect them kind of curvy like that. The domain and range of your cubic graph, those are easy because for the domain and the range, it's all real numbers all day, every day. So anytime you have a cubic, they're nice. It's all real numbers for the domain and the range. Easy peasy. The domain and range for my square root graph, it's going to come exactly from these numbers. So domain always goes with X, range always goes with Y. So the X is always going to go with that X value. The range is always going to go with the Y value. All we have to do is figure out which way the inequality symbol goes. For the range, it's always going to be bigger than. So if I'm at -5, my graph is to the right because we're not reflecting the other way. So it's always going to be greater than or equal to that. The range, though, if your graph is facing up, then it's a greater than. For this one, your graph is facing down, so the range is going to be a less than. And for the domain, it's always greater than. So you just match up the values. So you don't have to wonder where it's at. It comes from these points. That goes with X, that goes with Y. For the domain, it will always be greater than. And for the Y's, it's greater than when it's facing up and it's less than when it's facing down. And that is really it.